How about now?
Yep.
Cool. Yeah, so I just Google Arduino ID and it's the first thing that pops up. You come here and it's actually available for Windows, Mac, and even Linux. You can choose whichever you have. For now, I'm just gonna go with a Windows installer. If you have a Mac, you just go for the Mac one. And you can decide to donate to them or just download it. And yeah, it's a little program. This is what you use to communicate with the Arduino. It also works with other boards that are outside of the Arduino family. It's pretty cool, actually. But yeah. Okay, I'm gonna install it. Well, I already have it installed. Oh no. But you guys will have to install it. I'm gonna give you a couple minutes so you can get that ready. And let me know once it's done. Yeah. Whenever you guys have it, just type in the chat and we can get going. Meanwhile, I'm gonna, oh, okay. Yeah, Charles, I know. Meanwhile, I'm gonna get, I'm gonna start talking about more or less what we're gonna do in this workshop. I mean, you guys already started building your robot, and you guys can see that we're having an Arduino. We have a ultrasonic distance sensor, which is the same one that we used for previous workshop. We also have what looks to be a motor driver, and it's known as an H-bridge motor driver. I'm gonna explain it more or less in the workshop, but this allows us to control the motors in such a way that you can tell them to move.
Where'd he go?
Miguel, we can't hear you at the moment.
Oh, hi. My bad. I don't know if you guys were able to hear all along or I just, oh well. You guys have already installed the IDE? Okay, cool. I'm gonna get started. So yeah, this is a workshop done by UPE. This is our second workshop for UPE Make. We're gonna have a couple workshops for shell hacks, which is
I'm not sure you're sharing.
Oh God.
Are you?
No, I'm probably not. I'm gonna try it again. I think it crashed. Thanks for letting me know.
No problem.
Let me have the chat over here. Yeah, so this is this is our second workshop for UPE Make. We're gonna have a couple workshops in shell hacks, and if you're interested, definitely check it out. It's gonna be computer vision and Fusion 360, I believe. Our friend Charles is gonna present them.
Yeah.
We also have the upcoming workshops for regular Make, which is gonna be October 1st, 3D modeling with a 3D pen. We also have 3D modeling advanced on October 15 and Raspberry Pi on November 9. Those are pretty cool workshops. We have a Discord, but you guys already know, but you can always join it. Our social media. And yeah, today we're gonna be working on an object avoidance robotic car. The way that this is gonna work is it's gonna move forward and it's going to constantly detect whatever is in front of it. As soon as it detects anything that is closer to a certain range, what the robot is going to do is it's going to move back at a certain direction and then going to try again. And the trick with this is for any obstacle that you have, if you keep trying and moving back and keep trying, you're eventually going to be free of the obstacle, more or less. It's not a very elegant solution since we only have one sensor, and we're actually going to be rotating it a little bit meanwhile we're driving, so we can actually get a wider angle out of it. But it's definitely a cool project to get started and to implement all of these sensors together into one working prototype. You guys already know the materials. We have our frame. We have two DC motors, a wheel. We have our servo motor with our servo motor mount. Then in that mount, we get the ultrasonic distance sensor. And finally, we have an H-bridge DC motor driver. The H-bridge is really important to be able to allow us to control the motors in both directions and to set a certain speed to each of them. You guys are gonna see it, but it's actually pretty cool. And yeah, finally, the Arduino shield. In our case, we're using an Arduino shield because it just makes the connections easier. If you didn't have an Arduino shield, you will need to do all those connections using an external breadboard, which just makes things a little bit more clunky, but it's definitely possible. We're just lucky to have this shield with our kit, so let's just take advantage of it. I'm gonna start by explaining what DC motors are. And if you see here, you basically have an armature that has a constant magnetic field. However, inside of that armature, you have two coils. And those coils are basically having a different magnetic field. And the way that it works is like the outside is having a constant magnetic field, but the inside is constantly switching. You guys may know from the induction laws that if you grab a coil and you put a current through it, this coil will start having a magnetic field of its own. And you guys can see that we are actually having two brushes getting in contact with the inner coil. And basically the way that this is gonna happen is first you're starting out with the positive in one side and negative in the other, but once you start rotating, the actual polarity is gonna shift, and that's how the robot, that's how the motor keeps turning. Having this into account, you can realize that by putting a positive voltage to one side and ground to the other, the motor is going to rotate one way. But if you wanted to rotate the other way, you would need to physically switch the cables to be backwards. For example, you will need to connect the positive to this side and the ground to this side. This, of course, gives us a couple challenges. We want to be able to go forwards and backwards in a robot in real time without having to physically, switch the cables every time we want to change a direction. How would we do that? That's where the H-bridge driver comes into play. And also, imagine you wanted to have different speeds. The cool thing about DC motors is their speed changes more or less linearly depending on the amount of voltage that you give it. And if you wanted to change the speed without a motor driver for them, it will be kind of impossible because you will be only relying on the voltage of your batteries. However, the motor driver is able to to actively change the voltage that you're giving the motor so you can have the speed that you want. This may not make a lot of sense right now, but it's gonna make all more sense once we get started programming it and playing with the motor driver. So yeah, how do we overcome these challenges of using a DC motor? By using an L298N motor driver. This is known as a dual bridge, as a dual H bridge motor driver. What does that mean? I mean, what is an H bridge? Here I have this kind of, well, let me go back. I actually made this so you guys can visualize what an H bridge circuit is. Imagine you have your motor here. If you put a positive voltage to one side and a ground to the other, this motor is going to rotate some way. However, if you flip the polarity and you put the positive on the other side and then a negative here, it's going to rotate the other way. So what the H-bridge circuit does is basically once you want to rotate one way, it does this. So one side is connected straight to positive and the other one is connected to ground. However, once you're done with that direction and you want to move the other one, it just does this. I hope you guys can see, but this allows us to change the direction of the motor in real time without having to actually change the cables physically, which is pretty cool. The H-bridge circuit also allows us to change the voltage going to each motor, and this is going to allow us to actively change the speed of the motor. Yeah, this is a topic that we went through in our previous workshop, but we control the speed of the motors with PWM signals. And as we already know, Arduinos, you can send them a PWM signal from a range of 0 to 255. That is basically going from 0 volts to 5 volts. The closer to 255 that you see your signal, the closer it looks like this. And the closer it looks to 0, the closer it looks like this. But yeah, we already went through this in our previous workshop, so I don't want to take too much time on this. Let's go ahead and look at what the H-bridge motor driver looks like. We first have, and we already did it, we already connected this. We have our VCC. This is the voltage coming straight from the battery. As you guys can see, our LN298 actually can take from 7 volts all the way up to, I think, is 15 volts. So if you have any kind of battery, and for example, some of you guys have a 9-volt battery, or some of you guys also have like a couple AA batteries, and you're able to use all these different kinds of batteries without worrying, because our motor driver kind of accepts a big range of voltages. And yeah, you don't really have to worry. This is actively changing, like this circuit right here, inside of it has voltage regulators that take care of, changing whatever voltage you give it to the voltage that it needs. I hope that made sense. So yeah, we have our VCC, which goes directly to the battery. Then we have our ground, which also goes to the battery. We have a 5-volt. We have a 5-volt output pin, and some of you guys, specifically the ones that are using the 9-volt module, the 9-volt battery module, you are actually able to take out a 5-volt signal from our L298, and you can use it to run any device that uses 5 volts, for example, an Arduino. We also have on the right and the left, we have the outlets for the motors. This is for one of the motors, and this is for other of the motors. finally, what I believe is most important is down here. This is what basically we use to control the H bridge part of our motor driver, pretty much. You have in the corners 2 enable pins. By default, they have a jumper inside of them. I hope you guys already took that away, because if you take it away, you can actually give the enable pins your PWM signal. Anyone has a question? Okay. If you send a PWM signal through the enable A or the enable B pin, you're actually going to be able to control the speed of the motor. So if, for example, if you give it a PWM signal of 255 to enable A, well, the motor A is going to move at full speed. But if you give it a PWM signal of 0, then the motor A is going to stop pretty much. The same happens with B. Then you have the in1 and in2 and in3 and in4. You basically use the in pins, which is the input, of course, to select basically the direction of the motor. If you have in1 high and in2 low, the motor is going to move one way. However, if you have in1 low and in2 high, the motor is going to move the other way. That also applies to the other in pins. And we're going to actually program this in our code. So yeah, let's test it out. Let me get Arduino. Wait.
How will we be connecting the motor? Would we be like, would we have to solder anything or just like twist the wire?
Were you able to follow the guide?
Yeah, but I saw that we didn't do anything with the motor wire, right?
Okay.
Yeah, so there's no soldering. All you have to do is use your screwdriver to put it into place onto the motor driver.
Okay.
So you would have to, I mean, you don't have to strip it. It's already stripped, but if you want, message me privately and I got you with that, okay?
Okay.
If you see your motor, it's gonna have 2 wires, each of them. One is red and the other one is brown, right? Or
Yeah.
black. You see how we have this in the right and the left?
Yeah.
You have these 2 outlets and these 2 outlets. You should be able to connect one positive to one of them and one negative to the other one, and the same here and here. You don't need to solder it. It's just using a screwdriver. You can actually put the cable and then screw it in.
Okay. Is the red like going to a particular one or just do it any?
The cool thing is that it doesn't matter because you can fix it later in code.
Okay. Thank you.
No worries. If you have any other questions, let us know.
We're obviously supposed to connect our Arduino to the computer, right?
Pretty good point. Yeah.
Yeah.
We wouldn't
Just
get
making sure.
very far without it. I actually have my own robot here, but Charles has his own, and I think it's better for that. Let me get my cable. So, as I already pretty much showed you guys, okay. I think I ran into a problem. Oh, there you go. I got it. So yeah, of course, first step, let's connect our connect our Arduino. It's just kind of disappearing, but you connected with the cable, the USB cable to your computer. Charles is showing how to. For now, we're just gonna do a test code so we can make sure that our Arduino is working with our computer and that everything's fine. Yeah, I'm gonna wait for you guys to do that, and then all you're gonna wanna do is basically we're gonna have our Arduino send us some message. So serial.begin 9600, and then in here in the loop I'm gonna do serial.print ln hello world, and I'm gonna have a delay of 300 milliseconds. That's all we're gonna send. If you connect your Arduino, well, before connecting your Arduino, and this is kind of tricky, you should go to tools. There's gonna be a couple options here. First, you select the board that you have. In our case, it's an Arduino Uno, so that's fine. But then you need to select a port. Now, I haven't connected my Arduino yet, and I see that the ports 3, 4, 5, and 6 are showing up. Look what happens after I connect my Arduino. Okay, I connected it. Let's just wait. Now the port number 10 appeared, and that's how you know this is the port of my Arduino, because after I connected it, it happened to appear. I want you guys to connect your Arduino and see if there's a new port appearing. And if so, just select it. So just to recap, I connected my Arduino. I saw that a new port came on. I selected it. And after that, I'm actually able to upload my code, which is a simple one. And you guys can see that I'm getting the messages, hello world. So it's working. If I have any feedback, I can even click on ports. You don't have an option to click on the ports? Like just here. Let's try it out. I don't know what to say. Usually,
I can do a little bit of research really quick to check.
If you have a Windows computer,
mention device manager is really good.
If you have a Windows computer, you can always go to device manager. Here you can see the ports. Here you see all your ports. This is how my Arduino looks. USB serial port COM10. Whenever you connect your Arduino, it should show up in your device manager. For example, now I disconnected it and there's nothing. But once I connect it, the new one comes in. So yeah, how many of you guys were able to successfully get it to work? Okay, you got it right? That's cool. Yeah, I just want to make sure because this is pretty important for the beginning. Well, if that's the case, I think I'm gonna keep going. If you only have one port, usually Arduinos should work straight out of the box. You just connect it and it's already seen by Windows. So yeah, you should be able to just start the serial communication. Oh, that's cool. Okay, I'm glad to hear. So if every one of you guys have it working and are able to read the hello world message, I'm actually gonna keep going in the workshop then. So something that we saw here specifically, we have our enable pins, our in and out, sorry, our enable pins, our in pins, and finally an other enable pin. What I'm gonna do is I'm gonna define all of the pins that I'm using. In my case, enable A is 6. And this is basically what you guys did when you were building it. If you see the little letters in the motor driver, you can see that the enable A pin is connected to pin 6 in the board. So we're basically just writing our code, which pin has which. Define enable, sorry. N1 is gonna be 7. N2 is gonna be 8. 9. 10. Yeah, this is basically all the enable pins that we have and the end pins. After that, I'm gonna bring, I'm gonna create an enumerator. And this is something that is more advanced, but basically what it's gonna allow us to do is to give names to each of the motors. We're gonna use this later on when we're creating a move function, but usually if you wanna select between two things in code, you do it either with a string or you do it with an integer, putting like 0 or 1. Well, doing it this way is gonna allow us to give names to basically an integer. Left is gonna be a value of 0 and right is gonna be a value of 1. This is gonna make more sense later on, but yeah, once you have that ready, I'm gonna get rid of our test code and let's go ahead and initialize our pins. So we're basically telling the Arduino that I want all these pins to be output. I'm gonna go ahead and copy it. And I just change it to each time. It's very important that you stay consistent with your variable names. And if you have any questions about what I'm doing or why I'm doing it, feel free to ask. I love to answer the questions. By doing this, we essentially told the Arduino that we want those pins to be either output or input. Now, as I already told you guys, if I set my enable A to be a PWM signal of 255, then that means that the motor A is gonna go at full speed. And then if I set, for example, this is gonna be .255, right? And then I need to set both pins in IN1 and IN2 are connected to motor A, right? So if I set this one to be high, digital write, and I hope you guys can read. This is probably too small. I'm so sorry for that. Is this better? Yeah, my bad. Digital write, IN1, and this is gonna be NA 255. If I set this one to high, and then I set the other one below to low, the motor is gonna go at full speed into one direction. However, if you flip it like this, it's gonna go full speed into the other direction. So yeah, let's go ahead and try that, right? So well, one second. This is actually analog, right? And then I have my 2 digital reds. Oh my God, digital here, there you go. IN 2, high. If I go ahead and you connect your Arduino to the battery, right? Basically, you either turn on the switch on your battery, on your 9-volt battery, or you connect this cable to the Arduino. Whenever you want to run the motors, you need to connect the battery to the Arduino, because the battery is the one that's going to be running the motors. You cannot really run the motors just with the power of the Arduino by this cable. So and I hope Charles can show you better, but we're basically connecting either this to the Arduino, or we're setting on we're turning on the 9-volt switch. So we're giving the Arduino power. If I run this code right now, let me connect my battery. Okay. 1 second. We're having a problem here. For now, let's just comment this out. Okay, I did this, and I don't know if you guys can see, one of my motors is rotating. Were you guys able to get one motor to rotate by doing this?
Yeah. How do we stop it though?
You can disconnect the battery. But yeah, that means that our motors are working. What to click? You have to upload your code. Yeah. Vincent had a question. What's the difference between define and just setting those as a constant pin? There is no difference at all if your pins are gonna be the digital ones, since those pins are set like 6, 7, 8, 9. But you start getting into problems using constant. For example, I don't know, pin 4. This will be totally fine. This will be totally fine to do like that. But once you start using the analog pins, you do them with, and this needs to be an end. The analog pins, you do them with a letter in the beginning. And if you are using constant, then that's a problem, because then you will need to use a string, and it just gets more complicated to work into the code. The define one, it just allows us to call the pins whatever we want, and there's not going to be a problem. I have someone that they're, yeah. I think Charles is going to help you out. Just 1 second. Okay. Since one of our motors is working fine, I'm gonna go ahead and let's develop the function that we're gonna use. I wanna have a function that looks like this. Void go. I wanna be able to give it the enumerator of motor. And a speed. So what I want this function to look like or work like, right, is basically, yeah, for now, comment this out. What I want our function to behave like is you just say go, select the motor that you want to go, and then a speed. The speed will work from 0 to 255. The initials, for example, if we go one direction, I would put a positive speed. If I want to go the other direction, I would put a negative speed. So a good way to do this, to achieve this behavior, will be, for example, by doing a function like this one. And it's taking our enumerator value, and then it's going to take the speed. This is the enumerator, and this is the speed. So, for example, if our m is equal to right, then you could say that the pins I and 1 and 2 and finally an analog ENA of speed, right? If our motor is set to be right, then we have a digital right, high, low, and then we set the speed. Now, what if my speed is negative? You know, like here, I put it a negative speed. Let me turn on my light. Okay. What if you have a negative speed? Then I would want to switch my pins, my digital IN1 and IN2 pins, so it goes the other direction. So actually, the best way to take this into account will be, instead of doing that, first you check which motor you have. If it's right, you do something else. You do the other case. You could also do else if m equals left. Pretty much, it's the same. For now, I'm gonna stick with else. Inside the first if, though, you would check, hey, is my speed greater or equal than 0? If so, I want my, okay, sorry guys. Low to right. And finally, we can set our analog speed, analog right. Okay, this is in the case that our speed is positive. If our speed is positive, I'm gonna set one of my pins to low, the other one to high, and then my enable pin will be speed. However, in the case that my speed is negative, what I'm gonna do is basically copy this thing. I'm gonna switch those pins, and then I'm gonna do negative speed. And this is basically gonna allow us, so if we set this to be right and then negative, this is gonna run. If we put it positive, this one is gonna run. And yeah, basically we do the same for the other motor. You can go ahead and copy this, or you can write it out. I'm gonna write it out. Speed is greater or equal than 0. IM3. So in this case, IM4. High, low, negative speed. Yeah. If anyone gets lost. Yeah, we actually have a copy of this code right here. If any of you get lost, you guys can always ask and we can send that to you through the Discord. But pretty much.
Sorry, go over really quick one more time what exactly that's doing. Like I get that it's controlling the right motor and what it's telling it to do.
Okay. Yeah, it looks a little bit complex. It's basically because we want to have a lot of functionality into it. I want to just have like the easiest function ever where I can just do go and then do left and set the speed to either be positive or negative. If it's positive, the motor goes forwards. If it's negative, it goes backwards, right? If I do 150, this range is a PWM range. So our Arduino can actually do PWM from 0 to 255. So that's the bounds that you will have when setting the speed. If I do minus 150, I want it to go the other way. We already saw, imagine I do this, right? And then I do minus 200. We already saw that if we want to go one direction or the other, we just need to flip the state of the pins IN1 and IN2. Basically what's happening is we're calling the right enumerator. Then this code is checking, right? If we type right, this code is checking for it. And then it checks for the speed. If the speed is greater than 0, it's gonna move the motor one direction and put the speed equal to speed. If the speed is less than 0, aka a negative number, it's gonna put the motor to turn into the other direction, and then it's gonna do the negative speed. Since you cannot really give a motor an actual negative speed, you're basically multiplying it by minus, just so you can have at the end a positive speed. You could also do something like math the absolute value of speed, and that will be the same. But I don't know, it's just easier to do negative. I hope that answers your question. The same is happening with the other one.
Okay,
the
got
else,
it. So
the else, yeah.
So the second else is like if it's left. So the first else is if greater than or lower than.
You could do it exactly like this.
Okay.
And it will be the same.
Yeah. Got it. Okay. Thank you.
No worries. I'm gonna uncomment the enumerator, and it's pretty weird because it was giving us an error before. And I'm gonna check. Well, just 1 second. But yeah, what happens if I run it now? Yeah, trying to use motor without a previous declaration. I'm gonna just give me 1 second, and if I cannot figure this out, then we can use normal integer values. But that wasn't happening before, for sure. So enumerator, motor, okay. I see. You're supposed to use brackets. This is important, guys. Use brackets for the enum. Yeah, it's silly. If you use brackets, it doesn't have any problem. You guys should be able to, yeah. Charles, if you haven't gotten this all written down, Charles can DM you the code so you can test it out. But what I'm gonna do now, I'm just gonna connect my Arduino to it, and I'm gonna upload it. Actually, yeah. So what's happening now? We have to see it. We have our go function, which is really long and all. But what's actually happening for the robot is going through the loop, and it's just saying, oh, I need to go right at a speed of -200. So if I connect my battery, like I already uploaded the sketch, so I can disconnect the Arduino from the computer. And if I connect my battery to the Arduino, I can see how my right motor is moving backwards by a certain speed. If I were to change this to +200, and then I upload it, then the behavior is going to be different. My motor is going to move, to the other direction. If you guys are able to connect your Arduinos, just give it like go was not declared. Just make sure is just looking like this, and you're able to have it just like that. You can read through this and compare it with your own code and make sure it's working fine.
I'm still getting the motor error, the same one that had just shown up on yours. How did you fix that?
I changed because I have done this with parentheses, and it's actually with angle brackets. With brackets, sorry. Maybe that fixes your problem. It's called curly brackets, that's the name, yeah. That worked. But yeah, if you're having any errors, Charles can DM you the code. You can try and run that code instead and see if you still have the errors. If you still have them, well, I don't think there should be. The idea is if you grab my code and you run it, it should be able to work with your robotic car. And then later on, you can see what you did differently and maybe compare so you can debug it yourself. Since the workshop needs to keep going, I'm just going to keep going. So yeah, we basically set up the go function. And we're able to tell our motors to go one direction or the other. If I actually wanted both motors to go forwards, what I would just need to do is like something like this. And that's it. Both motors go forwards. For now though, I'm gonna get rid of that. I don't want my motors to run while I'm testing the rest of the code. And let's just keep going. Yeah, this is an example of what we did, more or less. How can we improve the test code? By creating a go function. We already did that. And this is how it looks like with the go function. Looks long, but it is useful. Now we're gonna get started with the ultrasonic distance sensor. This is really, we already went through this in our previous workshop. I don't know if you guys were able to attend, but basically, instead of setting it up ourselves, we're gonna use a library this time. And there's a library called NewPing, and it allows you to basically, it allows you to have all the functionality that you would want without having to actually do the, the dirty stuff, or the work of setting up an ultrasonic distance sensor yourself. I'm going to show you more or less what we need to do to get it working. All you need to do in the beginning, first of all, we need to include a library. And I want you guys to check this out because it's really important. See you, Brian. You go to Sketch, include a library, and then manage libraries. I hope you guys can do that. Once you click it, you're actually going to load the library manager. There's a ton of libraries that Arduino already supports by default, and those libraries you can access through here. If you end up needing a library that is not supported by Arduino officially, you can get them. You can download the zip file and go, to Sketch, include a library, and add a zip library. However, the library that we're going to use today is supported, so I'm just going to go ahead and do that instead. You open the library manager, and then you type here NewPing. And nothing shows up. That's pretty great. Let me try again. There it is. Just select the version, but I already have it installed. Basically, the way that it will happen, you will have a button here, and it will allow you to install it yourself. Once you guys have the library installed, you just have to click it, and it's almost instantly. Then up here, you can actually do this, include newping.h. This is how you reference to a library. We also, for this project, we need to create, 1 second. We need to create an object with the NewPing library. Oh, not again. I need to close this. Can you zoom out a little bit? Like this, or like this? Okay, I'm gonna do it like that. Just give me 1 second, guys. Yeah, whenever you're using, for example, this library, and this is something that is pretty common in any kind of programming language that is object-based, you need to create an object for the variable that you're going to be using. For example, NewPing, sonar. Sonar is the name that we're giving our ultrasonic distance sensor. You could give this any name. You could call it ultrasonic. Doesn't matter. For now, I'm just going to do sonar. And then you have, okay, before doing that, actually, you need to define the trigger and the echo pins. Those are the pins that we use to communicate with our ultrasonic distance sensor. So trigger pin is, in our case, it's going to be, I think, 13. Yeah. Echo pin is going to be 12. So I can go here and you just need to tell it, yeah, my trigger pin, open. It's also, this library also allows us to have a maximum distance. And I'm gonna go ahead and max distance 200. That's all I need to do for my, to declare our ultrasonic distance sensor. This is for the, and this right here will be for the motors. And here we're creating our object. So what this library allows us to do now is, you can, and it's pretty cool, you can basically create an integer called distance, and you go back and you reference our sonar, and then do this ping centimeters, and just like that, this is going to return the current distance of any object that is in front of our ultrasonic sensor, and we're going to basically give that value to this variable. So then you can come here, if you have a serial begin 9600, if you have that, you can actually then print the value of the distance. And it's better to use ln, so every value is gonna print in a different line. If I run this code right now, I'm gonna try and zoom it out a little bit. Basically what we did is we included the library, we gave a definition to the pins, then we initialized our sonar object, and finally we're referencing our sonar object with the ping.cm method, and then we print that value. And I'm getting 0. But if I move my finger, my hand next to it, I'm basically getting like different readings. Pretty much. Those readings are in centimeters. You guys can test it out, but by following what I did right now, you should be able to see readings in centimeters in your code. Something that you will notice is if the distance sensor goes out of range, it's just going to output the value of 0. Usually that is not something that you want, and we have to take that into account when creating the logic for a robot. But for now, if most of you guys were able to set it up and you have your serial monitor to output a valid distance in centimeters, then we can get going. Just, I want to hear your feedback. That's all. And if you guys have any questions, just let me know. Hey, your motor's running at all? Oh, okay. Are your motors not running, Charles? Okay, I'm gonna see. I hope most of you guys were able to get this working. You should have a reading, and that reading should move whenever you have an object getting closer or farther away. After that, I'm gonna keep going in the workshop since we only have 50 minutes left. So yeah, we did the code, and this is basically what we did. Something that I forgot, oh my God. This is probably why it's not working. We need to define the pins that we just used, right? Trigger pin, so sorry for that, guys. Let me run it now and see what happens. But it was working. That's pretty weird. Normally, you need to define them. Now that I defined them, it's not working. Gotta love it. Let me see what's happening. Okay. This one is input. There you go. Manner, that was for someone else. I will upload the specific code for each component. Okay. Something that you guys can see is it goes kind of wild if it's not sure if there's something in front of it. Usually when you're working with the ultrasonic distance sensor, you want to have delays in between every time that you're calling that function, because it just works way more consistent. I don't really know the reason behind this, but I imagine the Arduino is basically trying its best to keep up, and it's really not able to. But now that we have it like this, it runs fine. It's detecting my wall right now. But yeah, I'm gonna basically included the library, define the pins, then we initialize the pins here and set a distance, and then print it, and then delay. That's all we did. I'm gonna keep going. So our next topic is how to use the servo motor. Servo motors are pretty cool. I already went through this in the first workshop, but it's basically a DC motor connected to a gearbox. The gearbox is gonna enable it to have a better torque, higher torque. And that gearbox, the shaft, is connected to a potentiometer. And the potentiometer actually allows us to know the current location of the shaft the current rotation of the shaft in terms of an angle. In order to use the servo motor, we use the servo library, and Arduino already has that library embedded into the IDE. So yeah, this is gonna be also kind of a complex type of code, but basically what I want is I want my servo motor to check rotation in such a way. Okay, I don't know if you guys can see, but I want it to rotate like this and then rotate all the way to the other side, and like that, and like that. And just keep doing that over and over and over. In between times that I'm rotating, I want to also check for the distance. So it's going to look like this is rotating and checking for the distance, but what's actually happening is it's rotating a little bit, then checking the distance, rotating another bit and checking the distance, rotating, checking, rotating, checking, rotating. You guys get the drill. So for that, okay, I just typed something crazy here. We're actually going to create a new function. And it's going to be called, in this case, I called it move servo. Now, this function, I'm putting it right next to the loop. It could go all the way to the bottom. It doesn't matter. Whenever you're trying to use a servo motor, it's important to include the library. In our case, servo.h. In our case, for the servo library, you don't need to include it to the managed libraries, since that library comes included by default. So you don't need to worry about that. You just include it there. A couple of things that are important for the servo. I'm gonna go ahead and I'm gonna add my other variables. One of them is servo pin. My servo is connected to the pin number 3. What do I mean by that? If you see in your shield, we have the servo connected to the row that says number 3. Actually, one of those pins is voltage, the other one is ground, and then the signal pin is the actual pin number 3. That's the one that we're referencing here. The way that I want this to work is I want to have a couple of angles, and I want the servo to move to those angles. So what I'm going to do, I'm going to actually do a sensor angle. I want to do an array. If you guys have taken any Java or programming course, you have seen arrays, and they allow you to store numbers inside. Yeah, they allow you to store a lot of numbers inside of a simple variable, and then you can access each of those numbers differently. This is just a simple array. We're going to have 7 angles, and it's basically the servo is going to be shifting between those angles in real time every time. So 85, 105. It uses curly brackets. A couple more things that we're going to need, but it's going to make more sense later on. I want to have a variable that tells me the number of angles that I have. In our case, here we can see it's 7. Number of angles, and I'm going to put 7. I'm going to have another variable that's going to be my servo speed. Servo speed. This is just going to be the amount of time that I'm going to wait for each movement. And that's going to be basically kind of the speed. It's not really the speed, but it just makes it go faster or slower if we wait less time between each step or if we wait more time. Yeah, I think for now I'm gonna keep that way. So let's think. How can you access arrays? If you have an array, for example, if you have an array, for example, our own array of sensor angle, if you do something like this, for example, serial.print ln, if you do something like that, what the function is going to print is the number 45. If you instead put 6 on here, you're going to print this number. We can take advantage of this to create logic. What if instead of printing that, I want to just go ahead and move my servo? Usually when you want to move a servo, you just do servo.right, and then you give it an angle. Well, we can actually go ahead and give that angle, right? Well, this is not the actual code, but this is just to get you started into how you would think about this. So I'm going to actually delete it, and we're just going to start. Before using a servo, you need to define the servo. So we included the servo library. Then in the setup function, I'm going to do it after the pin modes. Well, sorry for that. After the new ping and declaration, you actually need to also create a servo object. So servo, my servo. Then in the setup, you're able to use my servo attach. Call that the servo pin. Since this is just the setup, I actually want the servo to move to the default location and then wait for 1 second. Yeah, it's gonna be recorded. I want the servo to move to the default location. In the beginning, it's just 90. 90 is gonna be the middle. So yeah, if I go ahead and I run this right now, well, let's see. My servo is looking to the side. If I go ahead and run it, my servo should go to the default location. Let's see what happens. Oh, you see that? It just went straight away. I set it to be 90 degrees, and now it's basically looking into 90 degrees. So that's just the start. I want this function, the move servo function, to be in such a way that every time I call it, move servo, like that. Every time I call it, I want the servo to keep going through the angles that we have in our array, and then do it that it looks like it goes one way and then the other. One way that you can do this is by having, for example, I'm going to declare the variables up here, but it's better if you declare them next to our servo variables. But imagine I have one variable called index, servo index, or angled index, right? This is gonna be initialized at 0. And then I'm gonna have another called angle step. This is gonna be 1. Oh my God, I did this in the wrong place. It has to be here, right? Well, I can pretty much, the first time that we run this, instead of having to use angle, sensor angle, and then giving it a number, I can actually just give it the current index, right? And we're gonna be manipulating that index in real time. So every time that I run this, I want the angle index to be added by 1 step. This is gonna make it so our index, for example, if I run this, it's gonna be, index is gonna be 1. If I run it again, index is gonna be 2. If I run it again, index is gonna be 3. If our angle index is greater or equal than the number of angles that we have, minus 1, why minus 1? Well, because our array goes from 0 to 6, but we have 7 angles. So if our index is greater or equal than our number of angles, I want the next time that this code runs, I want the angle step to be negative. So for example, we were moving our index and the index were getting 2, 3, 4, 5, 6. Instead of going to 7 the next time, it's actually gonna go 5, 4, 3, 2, 1, 0. Because we're constantly changing the angle step from being a positive number to being a negative number whenever you reach the limits. You also have the possibility, else if your angle index is lesser or equal than 0, then you basically change back the angle step to be 1. This is just the logic that we have, so we never go out of bounds of our array. Finally, I'm just gonna go ahead and tell the servo to move to the angle that I want to. My servo.write sensor angle, and then angle index. And I'm gonna delay. And this is where the variable that we created, servo speed, comes into play. Basically, the bigger the delay, the slower it's gonna be apparent, the movement. But yeah, this is the servo, the move servo function. I hope it makes sense. If any of you guys have any questions about the functionality, just let me know. I'm gonna go ahead and move these two variables that I created next to the servo function. Sorry, the servo variables on top. So everything's consistent. So yeah, every time that we go ahead, if I go ahead and well, that doesn't really matter. Well, let me just get rid of this. If I come here and I call the move servo function, it's basically gonna be moving the servo one step at a time. Every time you call that function, it's gonna be moving one step at a time. So let's see what happens if I run it. Okay, we have our first problem. Angle step. Okay, I am missing a parenthesis here. Is that all? Let's see. So what's happening is every time the move servo function gets called, we're moving through every single of those angles, all the way to here and then back and then all the way and then back. If you guys are still running the code and testing it out, test it out and let me know if you get it to work. But since it's kind of annoying, I'm gonna stop it. So yeah, that's how we get the servo to move. And this is pretty exciting because now we have all the elements that we need for a robot to work correctly. We have the motors, we have our ultrasonic distance sensor, we have our servo function. We just need to stick all these elements together into a working robot, right? So I say we try and go ahead and do that. This is how the servo test code looks like. But we already did this. And let's merge all our elements together. So yeah, I mean, this is what we have been working for the past hour and a half, right? So let's just do it. And this is by no means a very sophisticated approach. This is a very simple approach, but I think it's still pretty good and it works more than okay. What I'm gonna do is every loop, I'm gonna first read for the distance. So we know that if we call our sonar object and then we do the ping.cm method, this is gonna return our distance value in centimeters. If, and this is just to check for errors, if our distance is greater than 200 or our distance is less than 3, for example. I want our distance to go all the way to 200. This goes back to what I was telling you guys. Our our new ping library, whenever the sensor is not reading any distance, it likes to think that sometimes it just gives you a 0, even though it's not like there's an object really close to it. Or if you're reading something that is way farther, it may give you a value that is not correct. So we're basically doing this to avoid any problems. If there are values greater than 200, I just want it to be 200. And if our value is lesser than 2, I also want it to be 200. This is just so we don't have any problems. If not, the code will just, sometimes the car is running, and if it has a problematic reading, it's just going to stop in the middle of nowhere. We don't want that. So here's where the actual code happens. If our distance is less than the minimum distance, what is this minimum distance that I'm talking about? Well, let's define it, right? I would say that goes here with our distance sensor, maybe. No. Well, what is this value? This value is like the minimum distance that I want my robot to be able to get near to a wall or something before it stops, right? So I'm gonna call it minimum distance. It's a little bit confusing since we already have a maximum distance value on top of it, but minimum is, I'm gonna say 25 centimeters, right? So if our reading is less than 25 centimeters, I want my robot to go back. I want it to go back. If we're close to a wall, I want it to go back. So we can use our go function and do left minus 200 right minus 200. That would essentially make a robot go back. And then we wait, delay, basically for it's gonna move back for half a second. However, if our distance is greater than the minimum distance, that means that we don't have any object in our way that is closer than 25 centimeters. Then I just want a robot to go forwards. So left 200, 200. Now, if you guys can see this, realistically, if we get into a wall, the robot is just gonna go back and then forwards and then back and then forwards again. And that's not pretty much what we want. Instead, I'm gonna go ahead and change one of my go functions in the moving back. So it actually, one of the motors turns more than the other. So when it goes back with an angle. And this is gonna help it to get unstuck in most of the situations. And actually, I think we're done. This is the whole code for our project. It's funny because everything looks so complex, but then our loop function is kind of easy. You could definitely play with this more. For example, if you check that your angle was, if you check that you detected an object in one of the angles that are in the beginning, you can make the robot rotate a certain way. But if the angle is in the end, then you can make it rotate another way. We're not taking that into account. But if you want to get more complex with this, you definitely can. I'm going to go ahead and run the code and see if it works. It doesn't. Let's see what happened. I think I may have used the wrong. Yeah, I had a problem with my variable. I didn't define it the same way. Now it is working. So I should be able to connect my robot with the batteries. And what I see is trying to go forward, and whenever there's something in front of it, it tries to go back. I can actually put this in the floor right now, but you guys won't be able to see it.
I could try to see if I could get it to work and show you guys on the floor. Let me upload the code and then I'll see if I could show you guys. Pretty cool though, right?
Yeah, I know. I know some of you guys may have not been able to get it working. We're gonna be on the Discord. If you really want this project to work, we're gonna give you the codes and we're gonna be there to answer any questions that you have. The best way to go through this is just try and get each module to work. For example, first we get the motors to work, then you get the sensor, then you get the servo, and finally just stick it all together. But yeah, that's the whole point of our community in Discord, is to be able to help you guys. This is gonna be recorded and you guys can check it in our YouTube video for future reference.
Okay. Yeah, mine isn't working, but it's
isn't working? Okay, but is it the code or is the robot?
Let me see. I think it's a code. Yeah, but this is what always happens, you know, a lot of troubleshooting. Let me re-upload it.
That's weird. If you want, I can send you the one that I have.
Oh, wow. I think it's working.
It is working?
Yeah, I think so.
Okay, that's cool. Something else, you guys may have a situation where one of your motors, like when the robot is trying to go forwards, maybe one of your motors is not going the direction that you want. And that's happening because you can pretty much, you know, when you're setting the cables of your motors, you can pretty much set it in a direction or the other, and that can be messing around with what you want to do. If one of your motors is not running the way you want it, you just need to flip the cables in the L298 motor driver. And by doing that, you're gonna basically essentially have the motor run the other way. Once you get your both motors to run forwards when you want them to, and then backwards when you want them to, and you have all your sensors and everything working, this project should be working fine. If any of you guys is trying it and has any questions, let me know. I hope this workshop was fun and you guys learned something new.
Let's give it up for Miguel. Woo!
Whoa.
Good shit. Good stuff.
Thanks. Yeah. Yeah, I think that's it. I don't know if it's worth it to keep you guys any longer if you don't have any questions.
You guys are going to be sending the code though, right? Because mine kind of got messed, like it wasn't working with the distance sensor. And then it turns like now a little bit, but it's not turning too much. So I just want to play with it later.
One thing. I don't know if you're going to be doing it later. I recommend you to, you know, in the beginning, I have my servo code and it goes like, I have it to be 90. Whenever you send it to 90, your robot should look like this, like it's straight, it's looking straight, you know? If you go ahead and you comment out the whole loop function, and you just let the setup happen.
Okay.
And you can do this with the code that we're gonna send later. Actually, we're gonna send the final code and then we're gonna send a code for each of the modules that we're doing. So if you're having any problems with the servo motor, we're gonna have just a servo motor code and you can just run that. And if you get that to work, then it's gonna work in the final one.
Okay.
Yeah, that should already
Okay.
be uploaded on the Discord, but the final robot code, we'll upload it soon.
Okay, sweet. Yeah, because most everything was working, but not everything.
Yeah, and that's that's the thing with robotics and hardware projects. It's not like any other programming. It's not like any other programming tutorial, and since we cannot really meet, it's really hard to help you guys through. But I really want you, like, if you bought the kit, my goal is for you to get it to work. I mean, that's the whole point. And I'm gonna be on Discord, and Charles too. You can run this and just ask. Honestly, it's really fun to help. So I run the code, and my basically what this does is the thing is looking straight. If yours, after running the code, if yours is not looking straight, if it looks like that, what you need to do is unscrew it and set it as if it was straight. Because what's going to happen is you could have, and this is very common, it happened to me too, you could have screwed it the first time in the wrong direction, you know? But if you set it and you run it and it goes like this, then you just unscrew it and put it back in the correct location. Also try ahead and run the code. I know it's very easy to mess it, like to mess something with the workshop and everything. So you can reference what you wrote with the one that we're gonna send. Yeah. Any other questions? No, no worries. Yeah, I hope you guys liked it. I'm gonna stop the screen share.
Okay.
I guess
Yeah.
we're gonna call it a day.
Yeah,
right?
In that case, we'll end the meeting. If anyone still has any questions, make sure to ask in the Discord, and we'll help you there. And we'll go ahead and upload that final code for you as well.
Yeah, we have a meeting on Friday, right?
Yeah, we also have make hangouts every Friday.